lights behave as a wave? How does physics, the science of matter, and how matter interacts describe light? Well, in this video, you will recognize how do lights behave as a wave in different medium. Physics describes light as a type of electromagnetic radiation that is visible to the eye. It has the unique property that makes it both a wave and a stream of particles. These light particles are called photons. Then what does it mean for light to be a wave? Light acts like a wave, but unlike sound waves, light isn't a material that's moving back and forth. Because light travels in a straight line path and light waves across the electromagnetic spectrum behave in similar ways, when a light wave encounters an object, they are either transmitted, reflected, absorbed, refracted, polarized, diffracted, or scattered, depending on the composition of the object and the wavelength of the light. Now, one of the most important wave-like behaviors of light is reflection. It is reflected light that we see with our eyes. How light reflects off objects affects the colors we see as well. When a light wave strikes a new medium, some of the wave will bounce off the surface. How reflected the surface is will determine how much light and what wavelengths of light will be reflected, and how much will be absorbed or transmitted. Reflection involves a change in direction of a ray. The way to express the direction of a light ray is to indicate the angle which the light ray makes with a normal line drawn to the surface of the barrier. The angle of incidence is the angle between this normal line and the incident ray. The angle of reflection is the angle between this normal line and the reflected ray. According to the law of reflection, the angle of incidence equals the angle of reflection. The reflection of light is roughly categorized into two types. One is when light reflected from a smooth surface at a definite angle. This is what we call specular reflection. This is when rays of light are reflected off a surface in a single outgoing direction. Specular reflections occur in surfaces that are flat at the microscopic level, such as polished silver or a smooth body of water or mirror. The second type is produced by rough surfaces that tend to reflect light in all directions. This is what we call diffused reflection. This is when a surface reflects rays of light in a broad range of directions. Diffused reflections occur when a surface is rough at the microscopic level. The surface may appear or feel smooth like a piece of paper, but it is actually rough at the microscopic level. This causes the beams of light to reflect at different angles. Example: if you are reading a newspaper, the ray of light from our body is reflected, but the reflection is diffused. That's why we cannot see our image on the newspaper. But when light moves from one medium like air to another medium like water, it will change directions. This is a wave-like behavior and is called refraction. In this way, light behaves like other waves such as sound waves. The speed of light wave also changes when it moves from medium to medium. Example: when you put a straw in a glass of water, you will see how the straw seems to move to the side. This is the light wave bending as it enters the water. Well, it looks broken, right? The light above the water reflects from the straw through the air and glass to your eyes. But when the light travels through water below, the refraction causes the image of the straw to be in a slightly different location. Logically, in order to measure how light will behave in different substances, scientists use the index of refraction. This gives a ratio of the speed of light in a vacuum over the speed of light in the substance. The equation for the index of refraction is N is equal to C over V. N is the index of refraction, C is the speed of light in a vacuum, and V is the speed of light in the substance. The refractive index, as it's called, measures the bending of a ray of light when passing from one medium to another. The equation given means the higher the refractive index, the higher the optical density, and the slower is the speed of light. Example: the refractive index of a glass is 1.52 and the refractive index of water is 1.33. Since the refractive index of glass is higher than the water, the speed of light in water is faster than the speed of light through glass. So, if the refractive index of a medium is greater than that of another, then the first medium is said to be optically denser. Now, since the vacuum has a refractive index of 1, hence the speed of light in vacuum is faster than the speed of light in water, which is 1.33. Then another wave-like property of light is diffraction. It is when the light slightly bending as it passes around the edge of an object, or when the light wave encounter an obstacle or pass through an opening, they will bend. It is caused by one wave of light being shifted by a diffracting object. This shift will cause the wave to have interference with itself. It can be constructive or destructive. When the interference is constructive, the intensity of the wave will increase. Example, the silver lining around clouds and the patterns of light off the surface of a compact disc. So, if you learned new things today, drop your comments below, like and share this video, subscribe and hit the bell button to notify you in my upcoming video.